All right, well, let's begin. We're all set. I'm Bob Poland, Peri co-director, and we are again just thrilled, honored to have as our speaker this afternoon, Professor Anwar Shaikh. We were lucky to have him last Tuesday, and I won't go through all the details by way of introduction that I did last Tuesday, but a few things obviously need to be repeated, amplified, because we have a very distinguished person here speaking. Anwar Shaikh is the University in Exile Professor Emeritus of Economics at the New School for Social Research. He's made major contributions to the development of classical political economy on a wide range of topics, including in his 2016 book, Capitalism, Competition, Conflict, Crises. I read some excerpt from the review, a New Left review of this book, 2016, but just to quote one salient phrase here, the reviewer wrote, "The scope and scale of capitalism," the book, "are such as to invite comparison with Marx's Capital itself." Remarkable and deserved. So last week, Anwar spoke on, quote, some startling patterns of the empirical distribution of income by race, gender, and class in the United States, an Econophysics Explanation. Today, in the follow-up, he is going to continue this discussion with some startling patterns of the empirical distribution of per capita incomes within nations, an Econophysics Explanation. So we are looking forward to that. I want to just, as general ground rules, and Nicole, you tell me if I'm getting it right. Anu, you're okay with people asking questions, okay, any time? The only thing is we have an online audience, so people need to have the access to a microphone, and Jayati Ghosh is going to be the microphone distributor. That's good. So that means you don't have to do it. So that's the plan. Online people can type in the chat, right? Is that it? In the whatever it's called, the Q&A. And Daniel and myself will review the questions coming online. And so we'll try to give everybody, as much time and access as we can to communicate with our speaker, Professor Anwar Shaikh. So again, welcome, Anu, my former professor and still my teacher, Anwar Shaikh. Now, should he be using?
So it's a pleasure to be back here again. I've been coming here on and off for 40 years. Sorry, I've been coming here on and off for 40 years. And some buildings are much better than they used to be. This is a lovely building. I want to just reprise what I said last time, because this is an extension of that, and the foundation is very important. The stuff I'm going to talk about is actually something I didn't come to directly. I was doing work with my co-author, Amherst from New School also, on international data. And we ran into a pattern, which I'm going to show you, which we didn't understand. And so we started looking around, read the inequality literature, all the little indexes and measures, and then we ran across this econophysics literature by a man named Yakovenko and his co-authors. And it blew my mind, really, because here was a simple, clear derivation of all the patterns we've seen, but many others. So I'm going to try and show you that in 3 dimensions. One is for all data in the IRS. So except those of you who are foreigners, we're all in that data, and I'm going to show you that that data has amazing patterns which no one had seen before. And I'm going to show that the same patterns exist by race, class, and gender. That is to say, if you just look at white men, they have the same shape, not the same level, but the same shape of the distribution. The white women, African-American men, African-American women, all have the same distribution shape, not the level, but the distribution shape. And if so, everybody has that. That raises the question, what causes the distribution shape? Now, I should mention, these are pre-tax income. As I said last time, because they're pre-tax income, they are not directly determined by the policies of the state. The state can change the bottom part usually, but the pre-tax income is usually directly from wages and capital income. So this is caused by something else. And I would argue this is caused by the market. The market is a very powerful mechanism in capitalism, and it produces these patterns. So the last thing that we did was to try and show how the market could do this. And that we use something from physics called I'm losing the name, but anyway, Fokker-Planck equations, which are equations developed early in the century last century, to explain patterns of things that move in one direction, that's called drift, but also collide with a bunch of other factors, so that's called dispersion. Now, I would argue that's exactly what the movement of wages, of labor from low to high wages, or capital from low to high profit is. It's a drift and collisions along the way. If you start a business, by the way, you'll figure that part out quickly. So that then brings us to another issue, which is inequality among nations. And I'll show you that there's a very simple, clear relationship between one number, the GDP per capita, and the Gini coefficient. That is to say, with just this number, I can derive the Gini coefficient. And I can derive the inequality measure for different stages, at the top 80%, the top 70%, and so on, going down of the population. It's very handy because you could do this literally in your head. So let me start. I'm sorry, the secret to all of this is pattern recognition. Now, by pattern recognition, I mean that when we see data, there are many ways of looking at data. And that data can speak to us sometimes, in this case, speak to physicists sometimes. And then we see that there's a powerful insight which repeats itself through data of this type. And that's not obvious that it should, but when we figured out what causes it, then it became obvious. So, no? Or I go this way? No. No? Yeah, sorry. This is in the US. And I said last time that the key variable that we want is the cumulative frequency from above, because this variable has amazing shapes in two cases, and I'm going to talk about that. So we need to figure out how to calculate. This is IRS data here. How did I do that? Okay. Oh, down is back? Yes, no, it's the other way forward. I don't know how I did that. Yeah. Okay, I'm not gonna touch this, I'm gonna just point. This is IRS data, so it begins in this way, under 2,000, so on, all the way up to 10 million or more. Then there's a number of returns in that category. But since the 10 million or more is more, we have no way to calculate the midpoint. I think it's probably feasible if you go to the data with Piketty and Saez and all those, you can figure out a number, but I haven't done that yet. And the reason then is that this part here is not filled in on the data. But as you see, it doesn't matter. The pattern is very clear. So what you need is the bin midpoint. Under 2,000, the midpoint is 1,000. 1 million to 15 million, the midpoint is 1 to 50 million, and so on. And then what you do is you calculate the frequency. So if these are the number of returns and this is the total, then this is the frequency in this bin. And this is the frequency itself. Now we need the cumulative frequency from above. So first thing we do is calculate the cumulative frequency from below. That's this number here. And the second number is this plus this, or if you want that one plus this. Then the third is that plus this, and so on until the end you have the total population. Is that clear? And so if you do that, then the cumulative frequency from above is the reverse. You take it and you start 1 minus that, and then 1 minus this, and so on until you get 1 minus 1, which is 0. So you are counting, adding up for initially from the bottom, and then you're reversing that and taking it from the top. Is that clear? It's very common in frequency data, and you'll see the reason for this. The reason will come out in the patterns. I'm afraid to do this. Yeah. Okay, great. So this is if you take the IRS data and plot it. Simple enough exercise. Here's the cumulative frequency, which we saw before, going down from top to 0. And here's the income bins. And you can see here's 1 million, and these are the smaller numbers. But what? You see a pattern. What does that pattern mean? Well, economists have been trying to fit this pattern for a really long time. Different functions and different shapes and maybe some breaks. But look how beautifully Yakovenko's a physicist. Looking at this, he sees something that we don't see. And that is that. That is, yeah, wait a minute. Okay, I don't know. I guess I skipped one. Let me. I'm going up or down now? I think. Okay, here. Back. Oh, I see this one. Yeah, sorry. Mine goes the other way, so, okay. Okay, so now we do it for all the years. I skipped one, but if you take that data, which is here, which is the all data, you can see that it runs along this line, and so you can think of people like to fit it and all that. And Yakovenko says, wait a minute. First of all, this data has a point at which you're talking about, you're talking about wage income, and another point in the distribution, we're talking about capital income of the top 3%. And we know a lot about that. That's Piketty, Saez, and all of that. So what he does is say, well, in the bottom 97%, I'm going to put on a cumulative probability here, and the AGI, which is the adjusted gross income relative to the mean. And you see that if this is a log scale, then all of this bottom data becomes a straight line, which is to say it's log linear. And every year we put, these years, because otherwise it's hard to see, but it's true for every year. You can see that they all fall along the same line. This line is not an estimate line. It's not a regression line. It's just the data line that fits the whole sample. And you can see that it just is there. And you take more years and more years, you find they all fit on the same line. Now that, to me, was completely astonishing. And then if you take the top, which is basically here, you get a straight line if you take a log. In the bottom you take a log, and the top you take a log, and then you get a straight line. Why is this relevant? This shape is the characteristic shape of an exponential distribution. This shape is a characteristic shape of a power law, which is also called a Pareto law, because working in the 1870s, Pareto, the Pareto you all learned in game theory and all of that stuff, that Pareto was charged with measuring the income and tabulating the income of the top percentage of the population because the state wanted to know how much they could tax them. And so he did that, and he found that those incomes fit a straight line in a cumulative probability. I don't know how he did that, but he did. And so now it's called a Pareto law. It's a power law. So we see that in different years, the cumulative probability from the first 97% follows a straight line, and the cumulative probability, a log linear line, and here this follows a log-log. Now this data is available, I can send it to you, but you also go to the IRS and download it and play with it, and you'll see these patterns come up again. Now, of course, the immediate question is, what the hell is going on? I mean, how could this be? And that's what I reserve for the theory part. Now the question we began to think about is, what about race and gender? I mean, we know a lot about those distributions, but has anybody looked at the shape of those distributions? And so we did. No, that's the same thing, sorry, I went back. Why did I do that? Yeah, okay. Now, this data is from the current population survey, the CPS, and it has data on salaries and wages for all individuals. So here's the data for all. It looks like a nice line, you could fit it. But if you look at the bottom 97% on a log linear scale, you get that line. And to me, this is astonishing because you're taking different groups of people by race and gender, and you're finding that they sit on this line, a log linear line, if you're doing this, and a log line for the top. In other words, this is the same pattern. Now, if you think about it, that's sensible. These people are the same population, but subsets. But it's not obvious that they would fall on the same pattern, same line. Then we did it by gender. And because these are two different populations, here they don't fall on the same line, but they have the same shape. And if you look at the cumulative probability in a from above, in a log scale, you have these straight lines. Oh, I'm sorry, what did I do? These are males, and these are females. So again, we're finding the same pattern. And this, by the way, is spaced out over many different years because we thought of this, we tried to do it, and it's not so easy to go through these. And then we did the same thing for race. Here's the overall pattern, and then if you take the log linear, which is this, looks a log scale, and there's a linear. I keep doing that. You get here straight lines. Not the same straight line, because it's whites versus African Americans, but it's a straight line in each category. And then if you look here in the top, you get the same thing. Straight lines and straight lines for the Pareto distribution. Is this okay? Everybody? Yeah, you're all in there somewhere. Keep that in mind. Somewhere in this, you're a dot. Unless you're from abroad. Now that was CPS wages. But then we discovered, Joseph Stiglitz I was talking to him, and he said, well, wages are not the same thing as adjusted gross income because that has capital income too. And so we went to the IRS and we found data that splits out wages and other types of income. The bottom 97%, that other type of income is relatively small. But in any case, and that's why the adjusted gross income is the same shape. But this is wage income from the IRS. And you can see here that same curved shape, but if you put it on the cumulative probability on a log linear scale, it's a straight line in all of these different years, 1996, 7, 8, 99, 2001, and 2002. On the other hand, if you put it on a log scale, the top 3% is a straight line. Okay, so any questions about this? Because the next part requires a little bit of algebra, which I haven't done here, but it's simple enough. Yeah. One of those bottles is mine.
Hi, thanks. You mentioned that the top 3% has different kinds of income, and that's capital income. But what form does this income take? Is it primarily capital gains, dividends, anything else?
Thank you. We did that in another paper, but the answer is it takes many forms, because think of it this way. If you're in the top 3%, wages are not going to be what keep you there, right? And so what keeps you there is income from your different assets, investment income, whatever it is. Obviously, Donald Trump is part of that, and Elon Musk. And there is data, not for the top 2, 3, I mean, for the top 3%, in the data provided by SIAS. And you can get there. It's on the web. You can go look at it. And it's amazing data. They've done great work. So we know what the categories are. For me, it was not necessary to do that because I'm aggregating the income. That's what I had from adjusted gross income by the IRS. It puts it all together. But we did find a table where all of that is split up. And if you're interested, I can give you that citation. We haven't published that yet, but I'll show you where the data is so you can work on that. Yeah.
There's also an online question about why the 96-2002 sample.
Why?
Why these years for your sample?
Oh, because we have all the years, but you can't fit them on a graph very easily. So we have earlier years, later. These are illustrative. If you want to go through the IRS data and do it by 10 years at a time, you'll see the same patterns. Yeah.
So a follow-up to Evan's question. So you had earlier shown that the top 3% has a different distribution than the bottom 97. And you said the top 3%'s main source of income is capital income. But if I'm reading this correctly, here we are seeing the top 3% of wage income.
Yes.
And they also have the same distribution that the top 3%
That's
of.
right.
So is
wages,
it about the top
wages and salaries?
So you think wages and salaries includes capital income?
Yes, and let me tell you where. If you're a lawyer, you have something called a salary and a wage, but it's actually a percentage of the profit. If you're very high, if you're not Elon Musk, but something that you get an income, and the IRS splits it up. I have tables that show you the split, but that split is composed of what they call wages and salaries, and that's a very high number compared for individuals. You can also look at different components of capital income, which we did, but it's not in here. But the IRS has that data, a table. And the reason is that adjusted gross income is a number which is adjusted. And the adjustments come mostly in capital income. All those things that they count in there. So, and that doesn't change the data. And this is Stiglitz's question. If you do it for the bottom 97%, is the capital income. Let's say rental income of your house. You know, if you own a house and you rent out a room, or is that counted? If that's capital income, does it change? And the answer is no. These are quite small. Okay, so this is the easy part. The first paper we did, Amr, Raghav, and myself, was on income distribution by nation. And as we found that startling patterns there, even more startling than this, and we couldn't explain them. So we took a couple of years reading about income distribution, all the different measures, and then we hit these physics people, and we were on our way. The same whiskey works better for this kind of thing, but that's what they told me in England. Okay. These are propositions derived in various papers, but they're derived actually by Yakovenko, again, a separate set of papers, and they show you how to deal with per capita income. Actually, we did this, not Yakovenko, but he showed it for the Lorenz curve, which I'm going to show you in a minute. So what we were able to show is that, it's not the one. I'll just go all the way to the bottom. I don't know how I did that. I'm doing that. She could go all the way to where I was, right? Yeah. I forget what these things do. So if you press the green one, you jump up to the, to the end. Yeah. Thank you. I'm trying not to press any buttons here. No, I'm going to try it. Let me see if I can, at least the red one, okay, which is just this. So what we showed, what we can derive from the Yakovenko argument, because he derives it in a limited form, in a form for his own data. If you take the per capita income of some proportion of the population, 60%, 70%, 80%, in World Bank data, by the way, we're going to apply it, but this is a theoretical thing that he applies to the US. It's equal to a coefficient, which I'm going to describe in a minute, GDP per capita and 1 minus G. That's it. So this, if I say I want 70%, then the coefficient is 1. It can be calculated from the same data. So that means that the per capita, the income of the bottom 70% of any country, of a country, will be GDP per capita times 1 minus G. That's it. And I'm going to show you that later. This is what Amartya Sen derives as an adjustment to the Human Development Index. He takes this component and applies it to the Human Development Index to correct it for distribution, which is absolutely correct. It's not corrected for distribution, but he did it from a social welfare function, and people began to attack that, so he withdrew. So for the bottom 70% of the population, this coefficient is 1. For the bottom 80%, the coefficient is 1.2. For the bottom 90%, it's 1.25. This is theoretically. Yakovenko derives that from US data, but he derives it theoretically. I'm skipping the derivation because it would take some time, but yeah, Patrick.
income of the bottom 70%.
Yeah, here, well, if you take X to be, A of X to be of the 70%, then this is the per capita income of 70%. But it can be 80% or 50% or
Yeah.
60%.
Yeah, I mean, so, yeah, it's for whatever that portion is, and
Right.
then it's GDP per capita for the
GDP per capita is
nation as a whole.
the whole, yeah. And 1 minus G is the whole. This is a beautiful formula because it tells you that there's a direct relationship between the income of the bottom 70% and these two variables, and you just need to multiply them by a single number. Yeah, people can do it in their head. I'm not one of them, but if it's 1, I can do it.
So for the bottom 50%, would A be a lower number than 1?
Yes, it's a lower number. I'm going to show you the data. But the thing is that when you go down to 50, 60%, the data is rocky because in many countries, that data is not directly observed. It's estimated. The World Bank tells you how they estimate it, how they take it from poverty data, because in those bottom parts, people don't, there's no good measure of their income. The tops, because of taxing, there is.
Okay.
And we talk in the paper about the details of how the World Bank constructs these things and why they themselves say that they have to take surveys of a different sort to guess at that number. But at the top, they have it.
Okay, thank you.
Sure, thank you. Okay, so now here's the thing that we ran across that blew my mind. That's an old-fashioned term, by the way, but I really, in England, they say we were gobsmacked, which I kind of like as a word. So here is what the hell is it? This is the per capita income. I took it out of the, this is the per capita income of the bottom 70. And this number is your coefficients as 1. And you can see that in every country, they are almost at that number. I mean, this is their per capita incomes here. And this is the theoretical number. Now, when we hit that, we said there's no way every country in the world would have this number for this calculation, but it does. These include different distributions, obviously. But if you multiply the distribution by the average per capita income, you get this number. Now, go down. We do it for 80, 90, 60, so on, and each one of them has a number. All the other information is the same. It's per capita income in Gini. The 80 is 1.1, 90 is 1.25, and so you can calculate, and those results are very good. Now, this is the linking coefficient for 65 countries, the one that tells you the bottom 10%, 20%, 30, 40, and they're not so reliable at this end, as you can see. But here, you get very good reliability. So 90%, this is the linking coefficient. And since everything else is the same in the country, it's per capita income and Gini, this is the coefficient that translates that information into the per capita income of the 90%. And you can see here, what country is that? I don't know. I'm sorry, this is the 20%. No, they go from the bottom. The 10%, 20%, and you can see they're very rocky at low percentage, but because there's an average of 65 countries. But at the top, they are actually very good. And this is 90%, this is 80%, and this is 70%. 80% turns out to be a very good number because it doesn't depend on the mixture between 1 and 2 family incomes, households. And Yakovenko derives that, and that's very handy because this is a number that is going to be more stable. Here you've got mixtures of those two because the data is often taken from one or the other. So we call this the vast majority income. It's a very simple number, it's 1.1, and we can derive the per capita income of different populations here, different subsets. Now, one question we asked is, how does this change the linking coefficient, which is the only thing that you need to connect it to the other thing? How does it change over time? And we have here, you see in different countries, it does vary, but it's remarkably, I'm afraid to press these buttons here, yeah. Remarkably, I knew it. Damn it. I go back? No, it's going the other way. Okay. Okay, my fingers are too fat, I think. So you see that the coefficients vary, but look at the range. It's 1.14 and 1.08, and they are remarkably similar. And these are the different countries, very different countries: Germany, Finland, Poland, Romania, United Kingdom, Argentina, Costa Rica, Taiwan, Honduras, Colombia, Uruguay, Italy, Spain, Luxembourg, and Venezuela. That's in a range of about 1.1, and it's a pretty good range. It varies between 1.14 and 1.08 roughly. Okay, now as I said, A70, which is a linking coefficient for the top, for the bottom 70% of income in any country, and is very stable when you look at the database. Sen was working on the Human Development Index. And in the Human Development Index, an issue arose. You take into account education and income and a couple of other variables, but you don't take into account inequality. You should. So he came up with an index, which he derived from a social welfare function, and he came up with the measure, which is the adjustment for inequality, and that's this, 1 minus G times per capita income. But that is equivalent to the income of the bottom 70% of the population, because A is equal to 1 there, and it collapses to this. So what he was actually doing was modifying the HDI measure by the income of the bottom 70%, an inequality measure, right? And to my mind, that makes a lot of sense because it's allowing for how much variation there is in that income. You could do other income levels. In fact, we did that. We took the HDI and multiplied with different ones to see. Obviously, it doesn't change the movement of the HDI, but it does change the level. We did some other things, which I'm not going to talk about here. So let me stop there and open it up for questions. Yep.
Can I abuse my position with the mic? So,
You got the microphone.
so I'm trying to put this together. If you can go back to that chart with all the different levels of the different countries. You know, Gabriel Palma has all these studies on inequality. And
Yeah.
he's basically saying that what is remarkable is the difference in inequality rates across countries. And he says that what is common across all countries is the middle 40%. No, middle 50%. In other words, that's why Palma ratio, 10 by 40.
Right.
Right? And he's saying that if, in fact, if you take out the middle 40% or 50% of the population, which manages to somehow keep its share of national income in pretty much every country, except 2 or 3 outliers, you get massive variation across countries. And I'm wondering whether your 80% is a reflection of the fact that you've got, 30% lot in there. In other words, the Palma ratio is the top 10 by the bottom 40.
Right.
And you have got a whole bunch of, you have got another 40%. In other words, you've got the middle in there. And that is stabilizing
this.
This.
Linking coefficient. It's
Yes.
not-
Now, if you look at the lower level, the previous one. Yeah. You see how varied the lower levels are.
Yeah.
So it's really because, I mean, I guess Gabriel would argue that you're getting one because of the fact that the 80% contains 40% of the middle, which is very, very stable.
Yes, but remember that we can derive these, all of them, from not just observation, but from theory. And it's not a social welfare function. I don't have to say, I don't believe in social welfare functions at all, because I don't know where I am in the social welfare function. This is derived from the observation of the distribution of income in all countries, within and between. So we can arrive at similar numbers, but the meaning is different. That's a very important
So
thing.
what's the meaning here?
This is a linking coefficient, so what that, let me go back. That's it, right? Yeah, this is the GDP per capita income of the bottom X% times a linking coefficient, which is this, times just these two variables. Those variables are for each country going to vary because GDP per capita varies greatly across countries, and the distribution.
The Gini value.
Yeah, so that's where for us the action is coming, because the coefficient is constant. And so it's broken down into two variables only, GDP per capita and inequality. So that's the same principle, but it has a very different meaning.
I mean, I'm basically saying I think the same thing, but what Gabrielle is saying is that the reason you're getting that stability is because the middle half of the population in every society manages to retain its share. And he
Yes.
has a political economy argument for that, but that's the sort of regularity he finds.
Yes, but the question is why that's so.
So he's got, as I said, a political
understand,
economy
I
argument.
understand.
And so what's this one? How come this one happens?
And this one can help because we can talk about it for all different percentages. The middle percentage is not privileged here because we can't talk about, I mean, if you look at the bottom 70%, which is a very nice number, that is extremely stable across populations.
So you see,
80%
Gabriel
also.
would dispute it. He would say, no, it's the middle 50 which is stable. The bottom
Well-
40 is not stable. The top 10 is not stable.
Well, but the top 80% is very stable. I mean, this is income, this is,
Yeah, because that includes the middle. It includes 40% out of the 50%. It includes.
yes, but that's true of any higher number. I mean, it includes the 30% also. And I understand his argument, which is that the middle is very stable, and therefore the stability of the top comes from the middle. But we could actually test that fairly
Well,
easily.
he's basically saying that the class struggle happens between the top and the poor. The class struggle doesn't happen with the middle because you got to keep the middle guys happy.
Yeah.
Basically, I mean,
Yeah,
bottom,
I mean,
very simplistically
I
put.
I
He'd probably
understand.
kill me if I.
I mean, I'm looking at the US, I don't think that's true. There are other reasons why they have stability. I don't know that there has been class struggle in the US for a really long time, and that stability is here too. So yeah, I agree that we need to specify why that stability occurs. But here, the stability is remarkably the same for the top. It's not enough to say the top is stable. This top
Top is not.
is the same coefficient all the way through. And that means
So-
that we can translate the GDP per capita, which is not dependent on this, the Gini coefficient, which is dependent on the whole distribution, into the GDP income per capita of 70, 80, and those numbers are very stable. But I don't think here it's true that GDP per capita depends on the 50% in that sense, and the Gini coefficient, they do occur, but I don't need that here. I can literally derive it from just those two variables, and yes, 40% is there, but so is 60 and 70%. Yes, the 50 or 40% may be stable, but that
No,
doesn't follow
I'm basically trying
determining.
to think of the why
Yeah.
rather than, so why is it stable?
Keep in mind that it's stable in every country of the world, so
Yeah.
you cannot just make the class struggle. This is Sweden also, and the US also. So there is an argument here for the stability.
So,
But-
and why Why is there such stability?
We don't do that. I mean, it's a good question, but we needed to find out what it is you're asking the question about. And this is not the same
guess-
question.
Okay.
Yeah.
And why doesn't this graph include major countries?
Oh, we do. I mean,
No, United States, China, India, my
should
gorgeous
all
country,
be here.
Turkey, Sweden, Sweden is there, but the others, are not
did it
there.
again.
No China, no India, no Turkey.
Well, this is World Bank data, so I know you Turks are you're so easily, no, but look. I can't seem to, what am I doing? Yeah, I'm afraid I need the, oh, here, is that? Yeah, here. Here is US, Austria, Belgium, Brazil certainly, Finland, France, Germany. I mean, all the major countries are here. It should be the US is here someplace. Well, well, I assure you that this is data from the World Bank, and I'm sure they have it. I don't know actually why it's not in here. They have it. So
Well, the
I don't know.
original data was the US.
Pardon?
The data he started with was the US.
Yeah, so this graph may not cover all of them. I don't know. It's a very good question because they should all be there. And I think in our paper, they all were there, but I don't know what happened here. I will try to find out, since Amar's the one who knows everything. Yeah.
So this question also related to show the list of countries you had. Can you comment on the inclusion of self-employment and informal workers in the income distributions captured there?
This is the income calculated by the World Bank, and they give you very detailed. Oh, sorry. This is we use the World Bank database because we had no other way to go across the whole world. And we don't do the calculations, but they describe them in great detail. And they follow as much as they can the same pattern for all countries. I don't know the answer I used to know the answer to that, but I don't know to what extent they include that.
I know the answer to that.
Okay, yes,
Which
of
is
course.
that 90% of the countries that non-OECD countries that the World Bank has data for use consumption expenditure survey data
Right, that's
to
right,
estimate
yes.
income.
Right, they
Which is,
do.
of course, an underestimate of inequality and all
Yes,
of that.
exactly,
But
yeah.
that's how, and that therefore would include.
That's
other-
right, that's right. They tell you, the World Bank tells you where they have to use those surveys. And in more advanced countries have much better data, but they often have to use that. And there's some discussion about the relation between those. My colleague Sanjay Reddy did a lot of criticism of World Bank data and about the use of that. So I'm not saying that this is in stone, but I have to tell you, when we first saw it, we were blown away because they had no reason that I can think of for this, except that this is the necessary result of a division of the top 97% into exponential and the top 3% into power law. And that we did test country by country. So,
Also along these same lines, are any of your figures sensitive to purchasing power parity adjustments or any other cross-country adjustment?
I don't know that because I would have to go through every country in the world using World Bank adjustments. So I don't know the answer to that. I mean, this is World Bank data, folks. I didn't make it up. Yeah.
No, I was going to ask the same question. Are these official exchange rates GDPs or the PPP GDPs? No, but there's the GDP per capita that you're using in that equation has to use a GDP figure.
I don't know the answer to that either, because
What GDP does, GDP per PPP does, is it brings up poorer countries closer to the richer countries, and that we know.
right. Yeah. Yeah, because they have to be able to compare it. Yeah. Yeah, it does. Pretty much all data of this sort. But let me tell you, the pattern is still, I bet if you were to do that, you wouldn't change this pattern. So,
I noticed that on this graph, the lines, you know, the numbers, they don't really extend that much above the, you know, the 1.0 line, but they do, you know, noticeably fall underneath it. Do you think that's related to the fact that the US and China and India, Turkey and such are missing from this graph, or is that a separate effect?
this is by each country. So US and China missing from the graph just means one of the vertical bars. It doesn't affect the other countries at all. So when we look at the data for, why is that? Oh, I know, it's this thing, yeah. Okay. This is each country's own data. So that is not affected by US data or China's data. They should be aligned for China, yes, but each of these calculated separately. No, because we've done it for the US is exactly where we showed that the per capita income in the US is exactly this number. I don't know why that fell out. It's a very good point, but we have the data. And maybe that the graph extends in some way or something happened. I'll check with Anwar.
Thank you. I just wanted to ask if we could move on to the theory section. You mentioned that we were going to discuss the drift and diffusion mechanisms.
Yes, sorry. Yes.
Because I'm aware that time might be running out.
Okay, so very good point. What happens? Okay. Yeah. So in finding this data, by the way, for each individual countries, many physicists have been doing it for advanced countries, and they show the same patterns. So we're talking about something that is really, really widespread. But when they come to do this, these distributions come from physics collision of particles. And there are two types, thermal and the more heated superthermal. And the superthermal gives you a power law, and thermal gives you an exponential. Now, it's Yakovenko's brilliance to look at the data and say, wait a minute, this looks familiar in the pattern. Let me break it. Thermal and superthermal. Once he got there, he had all the tools, because physicists learned this in kindergarten. So he knew how to break it, and he derived many of these formulas from that. In my opinion, it's brilliant. But how do you explain it? And so what Yakovenko did is, let's suppose that every one of you is a worker, and you meet another worker, and you give them $1. That's particle collision, right? Because you exchange energy. And then you can show immediately that you get exponential. But I've always said that makes no sense. Workers don't need to get money from individual workers. They get it from their jobs. And that transfer does not create this. I mean, it creates lots of things, as Marx and others have pointed out, but it doesn't create an exponential. So then I began to think about this, and I was thinking about immigration. And what immigration struck me is the same principle coming across boundaries as it is within the country, which is that if wages are higher in the north, then the south moves, and if they're lower in Detroit, people move out and all of that. But they don't jump, they sort of say, okay, I think I'm going to go there, or wasn't what I thought. I was on my way there and I stopped here, I got a better job, or worse, I came back. That's diffusion. The drift is towards the higher income, wages or profits also, profit rates. And the diffusion is all the collisions and things that happen along the way. Now, when we began to think of it that way, then we realized we had a tool. And that tool is the Fokker-Planck equations, which were originally derived from these particle things, drift and diffusion. So I was able to show that when you bring it into this framework of wages, workers moving towards higher wages, then you get the exponential. And then it was more difficult to show about capital income because it's composed of two things, the profit rate and the amount of capital. We were able to derive that and get variables like of that. And then when we showed a drift diffusion, it came out exponential. Now that was not a quick process because I didn't know Fokker-Planck equations. Juan Jacobo, who was another co-author, taught me basically about these, but it was a beautiful moment when we showed not only you get this, but we could prove it mathematically. And that for me closed the whole loop. Because why is this happening? It's happening something really intrinsic to every country and every location, which is the movement of capital and labor, drifting. Now, who said that? Adam Smith. So it comes back to the origin. And everybody, Marx, everybody says the same thing, but Smith's the first one. Yeah, Patrick.
So I have an observation. It may be controversial. It might even be right.
Those are not exclusive, as you know.
And Becker was writing about human capital theory. The most popular equation in empirical economics, the log wage equation with age and age squared. Becker kind of made this observation that when you observe the distribution of wages in every country, it follows a log normal distribution.
Yes.
If you do cumulative distribution of the log normal and you take the fraction from above, do you get your equation?
The other way around. Let me go back to, I'm afraid to press this, but I want to go back, okay. Yeah, we did that in the paper, so.
Okay.
Okay, so if you take this distribution, this is the whole.
Right.
One of the ways to fit it is when you do a log, you get a curve. And what Yakovenko does, yeah, you get this whole curve. See this here? That's the curve. So what economists have been doing is try to fit a log normal to this.
Yes. But for the so okay. So that means kind of a couple of things. That means a couple of things. So like usually in studying wage distributions of inequality, you don't separate out the top 3%, whatever that top group is. But this sort of says you should throw them out.
Because
they're
their
not part of-
income source is different.
Yeah.
It's very important.
And typically in human capital theory, you explain this by looking at individual characteristics. But with your formula, you can then begin to talk about, well, what are some non-individual specific things that alters the distribution of income, that alters inequality, that will affect the bottom 70%, bottom 50%, or whatever? And what are some non-individual specific things that affects GDP per capita that can also have distributional effect?
The second part, I don't know, but the first part, inheritance. I mean, this is a very well-known factor that distinguishes the top from the bottom. and Trump is a classic example.
And maybe the reason for the noise at the bottom end of the distribution is unemployment. Maybe
Well, yes.
Because a lot of people at the bottom end of the distribution typically are sometimes you have, a high fraction of those people are moving in and out of unemployment. So they're going to have zero earnings, so they're not going to be included in the law. But the people in the middle.
No, I'm sorry, that's not quite correct. The IRS data begins from 0 to 2,000. So the midpoint is 1. And there's a number of people there. And by taking the midpoint 1, you don't have zeros. I mean, that's basically taking the average. You have to do that for every bin, otherwise the bin has no meaning.
But that's their income for the year.
Yeah.
During the year, they have been unemployed. So at the bottom end of the distribution, you have you have a higher percentage of people who have zero income for part of the year.
That's
And
right.
in the middle end of the distribution and higher, people tend not to have zero for any part of the year.
Yes.
So maybe there's another equation for that bottom.
I don't think you can take a log over 0. That's a big, so that's going to be the problem. But look, this is not meant to talk about every individual. It cannot possibly. We're talking about groupings. And to me, it's astonishing that with a stable grouping across different countries, across time, you get a simple law, a law which holds for different countries. And we showed you, I tried to show you. Anyway. Yes, no, I was thinking about that, Patrick. And so one of the ways I wanted to come to here, right, by race, right? So what's happening here is that these are for different years, so it's a little tricky. You should be having it for 1 year. Yeah, unfortunately, I condensed all the years. So, but in any case, if we take 1 year, the red one, and the top is the white and the bottom is Afro-American for, I think, that year. Now, what that tells us is that we can't tell where an individual is, but we can tell that the average individual is a certain percentage below whites, and that's a single number. So what we have to do is explain the variation around that single number, which we can derive without having to explain the whole thing. And I think in terms of formulating variables and formulating discrimination studies, as you first pointed out when I showed, this is not discrimination study, but this could be the basis by linking it to the differences among people, because then you have to say, if I take a person here and compare them to there, then even among whites, there's a difference because different years, but skip that. If I take it in the same year, then I'm going up to that same straight line, which is a simple formula. That straight line encompasses everybody in that band, in the band. And so we should talk about discrimination by bands with a fixed number between the average level of the bands. That's how I would do it. May not work. Then the question would be, how do we explain that? And I've done some work on that, but that's a separate issue.
My question is about drift and diffusion. The way you described the modeling, it sounds like there's a point in time at which the agents have not yet made their transition to, some appealing higher, they're trying to get a higher wage and they don't have it yet. And then it sounds like at the end of some process, everything is in, shall we say, equilibrium or whatever. I don't really understand how the model works.
It's not a model in that sense. It's a process that you observe. I mean, look, suppose you observe movements between, it's not by the individual, by the way, it's a measure of the group of particles, so to speak. Now, suppose you looked at people moving out of Detroit to the south, when Detroit collapses. Individual people, yes, they make it to there and they stop, but there's a constant stream of people who make it there, who don't make it, who go somewhere else, or turn back around. This is modeling the river, not the particular particle in the river. And so there's a constant flow. Now, you can break that flow. I mean, there are situations where you put up a wall, Trump wall, and that can change the properties of it. But within countries, that migration one way to the other and the diffusion is a stable process. It doesn't have to be an individual person. It's a stable process, and you can observe it over time by just looking at the numbers of people moving. Okay, so it's not taking an individual person, they go there and they drop out because other individuals come in. So it's not the story of an individual, it's a story of the stream.
Yeah, could you go to the slide or that has the time, I mean, the different countries with all the 10%, the 20%, no, the colorful one. No.
Yeah.
So, following up on Jayati's point, I mean, there is a lot of action actually, right? Up till we get to 80, there actually is a lot of change in the distribution by country, right?
So, yes, there's
so,
different levels and similar variation. See that too. You can see here that these patterns are, I did it again. No? Okay.
Yeah.
These patterns have a remarkable similarity. And even these, what's different is the level.
Yeah, but I mean, but you
correlation,
are
see.
also getting, it's not stable up to, say, the green line, right? There's a lot of very...
Yeah, there is.
Yeah.
And they're concrete factors, but also part of it is a measurement problem. We don't have good, World Bank doesn't have good data for that part. And so individual things are made up to fit. But I don't know any reason why they would all have the same internal pattern. They all have it, by the way. My guess it has a lot to do with GDP per capita movements or income movements. No, but we are ranking them by the Oh, yeah, but the countries. I don't think so, but let me think about that. I don't know. I don't know the answer to that. It's very clear that the pattern has some commonality.
Yeah, but I mean, but there is something to explain. My point is it's not always stable at all levels.
No,
There's something to
we don't
explain.
argue that in the paper at all. We say the top levels are stable,
Right.
but the bottom levels are not. And stable, look, folks, you're talking about 1.25 and 1.28. I don't know about you, but that's stable where I come from.
Well, okay, so then my broader implication question, so yeah, depending on how one interprets the variation, are you meant to be saying that policies that are aimed at affecting pre-tax income, and I know this is all pre-tax, such as minimum wage laws, have no impact on distribution? So we haven't, so that there is effectively no valid evidence suggesting, let's say, wage compression occurs as a result of a minimum wage.
I'm not saying that, but I'm struck by the fact that every year you have a particular pattern, and the question is how to fit observations about policy. And I don't know the answer to that. But coming from a base which is so stable, I would have to see what happens in when the minimum wage is raised. And again, that would be a great study that maybe you could do. I have to remember that I have to tell you, all this data, all this work is done by graduate students and me, and they get paid less than the minimum wage. So they get their name on this, they get a PhD chapter, but yeah, I'm sorry.
Yeah, along the same lines, these are questions from online. Should we conclude from the regularity across countries and across time that there are features of this income distribution that are inevitable? And kind of what do you see as the boundaries on this process?
I don't think they're inevitable because they don't talk about the level. They talk about the distribution. So if you think of that, yes, there's some properties that make that distribution pervasive. Whether it's inevitable or not depends on the circumstance. Let me give you an example, which is very important to me. In World War II, the Nazi regime had huge budget deficits, but it forbade businesses from raising prices, it forbade workers from raising wages, and it kept the central bank, kept the interest rate constant. They didn't have inflation because the mechanisms, at least from my argument, the mechanisms when you pump up an economy is when demand outruns supply. But if you don't allow those three variables to do that, that's how the demand is expressed, you don't get inflation. Now, in the US, I say the US, I think Nazi Germany first. In the US, Roosevelt did the same thing in the war period, beginning into war, end war. He froze wages. We told people if you did that, you're against the war. Prices, and the central bank kept the interest rate constant there too, with a budget deficit of what, 27% or something in World War II? No inflation. So that tells me that yes, of course you can vary these things. Of course you can affect these things. But you have to know what is needed and what the social context is. In England, this is called incomes policy. And they did it too in World War II. But to do that, you have to suppress the capitalist class, you have to suppress the working class and the financial class. Maybe you can do it. I don't know.
Okay, well, this is a good segue into my question. So I also have questions about trying to understand this drift into fusion process. And I assume from what you just said that there are parameters on the drift into fusion which are affected by policy, as you just described. The Roosevelt administration blocked off this kind of competitive drift and diffusion in a certain way. But is it an all or nothing thing? I imagine that there are different barriers to the movement of labor, different barriers to the movement of capital that are occurring in various countries over time and therefore affect the parameters of the drift and diffusion process. The river is being dammed at certain places at certain times. You talked about Trump putting up the wall. So I'm trying to understand the ways in which this drift and diffusion process over time and in different countries is affected by government structures and policies that direct or impede the degree of competition.
Needless to say, we didn't address that. But what we did look at in the US, using parameters, using the process of wage movement and the process of profit rate movements, very simple average parameters, because we didn't want Parker-Planck equations cannot be really solved if you keep changing the parameters each round. At least I don't know how to do it. If we were to somehow, I don't know the answer to that, but we didn't try that, that's for sure. It would be really good to try it, to see how sensitive these parameters are. Because the presumption usually is that the state can do anything it wants. Well, in World War II, it could do anything it wants, but it doesn't follow that that is true. And I would like to, if I would examine it, look to see what the drift and diffusion processes are in periods of different policies, not the World War II stop everything, because that we can say, but what about the post-war period in different, how is policy affecting it? And it should affect the drift diffusion, but it does not seem to affect the shape of the curve. Because we can see that, we can show that. So how do you go from these obvious effects to the fact that the curves, if you go to the curves themselves,
Well, if you do have these policies and barriers that are affecting the drift and diffusion parameters, and they don't impact the curves, the question is, are the curves being determined by something other than competition?
well, drift diffusion is competition. It's a fundamental principle of competition, which is arbitrage. And so I would argue that it is competition. And it doesn't say that all the curves are at the same level. What's astonishing to me is that they're the same shape. So they have a process of shaping and a process of leveling. And I did not look at that. I would welcome a look at it to see how it's affected in different policy periods. We know it can be affected. That's a point of the World War II example. But how big is the effect in, let's say, the Johnson era or subsequent eras and the Trump? I don't know the answer to that. I'm not even sure I know how to think about it, but it's a great question, definitely.
My question is, why you also choose 3% when analyze the wage salary curve? Because you already choose 3% considering the gross income. So when considering the wage and salary income, it actually excluded the a large amount of profit income aside. So why that's 3%?
No, we didn't do that. We split the curve into two parts to show that they had different shapes. But that doesn't mean we exclude the whole thing. The point is, if you're going to join them and you see that one has a linear shape in a log linear and the other has a log shape, which is going to be a curve, we show that that's a linear curve in a log-log. So we have a way to derive these, and it's always the same. So instead of taking a curve that fits all of them and which has different parameters at each point, this is a very powerful way, because then we can talk about what happens in the bottom 97 and the top 3%. That doesn't, we're not excluding the top 3, we're arguing that it's a different population. It has different laws, so to speak, and that's very important. I don't want to say that the laws of Trump's income are the same as the laws of the workers in Trump Towers, right? So that's the point.
Thank you. Could you go back to the chart? Sorry for the several decils.
Back from here?
No, the other one with several colors. I'm sorry. With several colors.
This one?
Yes, the same with Bob.
Wait, by race, this is the whole population.
Yeah.
Oh, yeah. Yeah, this one? Okay.
Yes, this one, yes, thank you. So if you showed me this in an exam, and I'm sure that my interpretation is probably wrong, given your answers, but if you showed me this in an exam, and you asked me, what would you conclude from here in terms of cross-country inequality, I would say that probably in terms of policy impact, countries are very good at impacting like the different policies and at impacting at the bottom levels, right? Because we have a lot of variation. Let's say in Argentina is not the same that for Belgium, right? For instance. And policy becomes very ineffective once you include, let's say, the top middle class. Like when you include the top middle class, when you go up, then in fact you have regularity, right? Regardless of the countries and their policies they are applying, we get sort of a flat line from the 70% upwards. But like before that. And given what but maybe, I mean, again, probably I'm very wrong in the way I'm interpreting this. What I would say is that up to that point, policies are being able to do something, showing some sort of cross-country variation.
No, I don't think so. Let me try to explain why. These are not variations across time. Oh, shit, I did it again. These are not variations across time. These are variations across countries. Oh, of course, but these are variations of a particular population percentage. And what's striking to me is that despite the variations, they cluster around the same number, the same line. And what's the hypothesis for that? Why is it that at 1, they're clustering around 1, at 0.4, they're clustering around 0.4, but they cluster? Yeah. No, this is, yeah, I'm sorry, lowest 10%, you mean we don't go there, but the bottom 40%, right? Bottom percent. That's, yeah, the bottom 40%. That, the link between that and the GDP per capita and Gini coefficient is a variable number, but look, I mean, why should it be around 40%? Why should the number have this property? Microphone.
You're talking about a difference in level for, between one country and the other. And therefore, as you're going up, you're basically saying that difference in level persists at 40, at 0.6, at 0.8, etc. And at one point, the difference in level begins to reduce and then disappears.
This is not a difference in level. This is a difference in a coefficient.
No. By level, I mean the value of the coefficient.
Yeah, but that's not a difference in income levels.
No. I'm saying that what it reflects is that there is, if I take 3 points, it tells me that between those three, among those three countries, there's basically a difference in the size of the linking coefficient.
Coefficient, yes.
And as I'm going up, that difference persists till I get to about 0.8. Okay? But once I go beyond that, the difference of between the linking coefficient across these countries begins to disappear. That's what is this. So in essence, as you're going to 0.8, because after all, as you're going up, as your linking coefficient is going up, you're going to a higher and higher percentage. So in essence, what we're saying is that the difference in the linking coefficient between countries somehow disappears when we get to whatever, 70% or 80%.
Right. We actually talk about in the paper and look at the income of what we call the rich and show that they're very similar across countries. That's correct, but this is a difference among the top population. And what we argue is the rich migrate, so to speak, merge across countries. Obviously, the others don't. So yes.
Yeah, I have been wondering this in my last presentation also, and in this current presentation, it's becoming more clear to me. One question for you is, like, in such an economy, like suppose what your data is presenting, what can be the policy level interventions, or what is the political economy of any form of intervention to reduce inequality across economies or within the economies? Or is there no mechanism, at least at the present political economy theories, in which we can address this? The reason I ask is because recently in Science, the journal where many scientists came into this conclusion in the editorial that, and also which was followed by other articles, that from the climate change perspective, reducing inequality is an important thing, which the scientists are also agreeing on now. So I'm just trying to understand from your presentation over the last 2 sessions, that what can be done in the policy arena or in the political economy arena to address this?
Okay, but I think people are misunderstanding what I'm saying. I'm talking about the distribution having the same mathematical shape. It does not say that the level of inequality is the same. For instance, these linking coefficients, shit, I did it again. These linking coefficients have relate the per capita income to the GDP per capita of the country and the Gini coefficient. And both of those obviously are affected by policy, right? So nobody is saying here that countries can't do anything. What I'm struck by is the similarity in certain aspects, right? And people don't talk about that. They talk about every country having this very large range of variation. They can do that. Well, how do you explain these aspects? And that's important to me because any policy discussion has to take into allowance what aspects are, what properties are tied in to something else, to the distribution in this case. So think about this, if this holds, we can change the per capita income. That's obviously a policy variable, not done very well, but a policy variable. We can change the distribution of the Gini coefficient. If we do that, then the linking coefficient, given the linking coefficient, you get a different per capita income of a particular fraction of the population, right? And that's the whole point I've been making all along. Now the question is, to what extent is the linking coefficient affected by policy? Right? Because that's what everybody's talking about, ignoring that these are the 90% variables, so to speak, right? The linking coefficient is 1.1, 1.0, and so on, and it's a stable number, though it has variation, or stable around a similar level. So if you want to talk about what countries can do, we know that. We can change the per capita income of the top 90%. But what we can't do is change it arbitrarily. And I think that's what's disturbing people in the response, that somehow you think you can change it arbitrarily. I'm arguing you can't. There's a linkage between the different layers of this cake. And yes, you can change it all. You can lower it. You can, at the bottom, yes, you can certainly slice it. This shows up. But there's a remarkable stability. So you have to explain in policy discussions why this comes about in every country. And you surely cannot say that capitalists in the US and capitalists in Brazil and Argentina and Ecuador are all doing the same thing. That's a structural property. So what's the source of that structural property? If you jump away from that, then you give it the impression that you can do whatever you want. And these are limitations. You can't do whatever you want. Sorry. Where's on it? Yeah.
Thank you. So I had two questions. The first you already answered. So I think what you just explained is that we should not interpret the linking coefficient as a simple measure of inequality. Is more complicated because it includes the ratio of the per capita incomes of the population of a particular fraction and the GDP per capita and also the Gini. So if we were interpreting that as a measure of inequality, that's not correct.
We
right?
derive it separately. I didn't put the equation here, but it's derived separately.
Right.
It does include the per capita, I don't remember, but I can go through the paper. We do derive it separately. So it's not just derived by taking these. Because see, this is the variable we're trying to explain here. And so there's a formula for the linking coefficient that has essentially the same variables, but in a different shape, in a different location.
And one quick question about capital income. So if you look at the distribution of capital income and break it into 97 and 3, do you see the same two types of distributions?
97 and 3.
Like you did for all others.
I'm not understanding.
So does the bottom 97% of capital income follow a exponential and top 3% of capital income follow a power law?
There is no bottom percent, 3%. You mean income in itself? Or
I mean capital income, the distribution of capital income.
I don't know the answer, but we don't have that kind of range in the data. We're talking of all income here. Wage income and capital income. I do have that because the IRS has it. But I don't know the distribution is essentially an exponential. Let me take it back. I do know. The distribution for capital income is essentially an exponential. The distribution for wage, is a power law. The wage income is exponential. But there's not much capital income in the bottom 97%. I mean, that's shown in the IRS data. So the big play comes from the top 3%. It is there. We do it because you remember I showed you. That's why I did it. Here. CPS, IRS. This is wages and salaries of the IRS. Whereas IRS, whereas the adjusted gross income of the IRS includes wages and capital income. And Stiglitz said, well, you're including capital income there, and it shouldn't be exponential, so you should take it out, which we did. And the reason the capital income is not influential here is because it's quite small. It rises rapidly as you get into the 90s. Not surprising. I mean, how many of us live on big estate incomes and all of that? It's small relative to wages. High wages may have high capital income proportion, but the proportion doesn't change it. I can show you the data. I mean, I can give you the data sources actually in our papers. So,
speaking of your paper, your co-author, Amir, is online, and he'd like to comment. And
he's going to correct what I said because he's the guy who taught me all this.
So what we're going to do is we're going to let Amir, the co-author, speak, and then Anu, if you have any wrap-up points.
Maybe.
And then we have a reception downstairs, and we'll end the formal discussion at that point. Okay, so Nicole is going to figure out how to let Amir speak.
Hello? Can you hear me?
Very sophisticated people here.
Hello? Can you hear me now?
Yes, I believe we can.
Awesome, good. So thank you so much for this. Let me just shed some light on the methodology based on the questions that came from the floor. Number one, the data is from the World Income Inequality Database, WIID, published by Uno Wider, the guys from Finland, the World Institute for Development Economics Research. And the data actually has over 4,200 data points, covering the years from 1970 all the way until 2015 for 168 countries. So the results are actually very robust, amazingly robust. And yes, in the chart, we displayed the data for the year that had the most number of countries. And yes, I'm sorry the US was not in that year, but I promise you the US is represented in many, many years. So just what you have there is a sample of the countries that had available data, I think, for the year 2014. But the US is definitely represented in the data. It's actually a very big data. So another point, very, very good question about how our results relate to the Palma ratio. And if we go back to try to reinterpret our results, what we found is that the Gini coefficient, the value of the Gini coefficient, which describes what you might call the overall or entire inequality in the system and income distribution, tends to go nearly one-on-one with the share of the bottom 70% to 80%. So any change in the value of the Gini, I automatically know there must have been some redistribution from the top 20 to 30% to the bottom 70%. But our results also show that for any given Gini, yes, you have kind of a given 70% share, but the share of the bottom 20 and the bottom 40 is not so fixed. So going back to Palma, what my results tell me is that the redistribution in income happens in two ways. There's a redistribution from the top to everybody else, and this distribution tends to be very sensitive to Gini, or maybe it's the other way around. The Gini is very sensitive to this kind of redistribution, while there's another kind of redistribution that happens between the lower tail and the middle part in a way that increases the share of the lower bottom to give us this variation between the level of the Gini and the share of the lower 40%, but not enough to change overall inequality. What it means in terms of political economy, I leave it to the experts, but basically that's how I interpret the results. Some reasons why the lower tail might have variation. Number one, some of our data are consumption data, so that tends to overestimate lower incomes. The whole problem of minimum wages, that also might lead to what we're observing. And also there's the issue of the quality of the data itself and whether it's gross income. Mostly it's gross income, but sometimes it's not too exact. Sometimes you have the problem of the one household reporting and the two-person household reporting. Two-person households tend to be less unequal. So there's a lot of variation at the bottom tail. It's hard to really pinpoint why, but these are the regularities that we observe over and over and over again in income distribution across countries and across years. That's it from my side. Thank you so much.
Amit, thank you so much. That was really helpful and explained a lot. Can I just follow up a little bit? Oh, no. Okay, I will email you, Amit. Thank you.
Thank you. Thank you.
What should I wrap up? Well, I can't do any better than that. So, as I said, I got into this because Amr said to me, I'm bored, let's do something interesting. And then 10 years later, we got this published. Everybody hated the paper. People were doing discrimination, people were doing the UN. Everybody hated the Cambridge Journal. As I said, I'm an editor, rejected the paper in a nasty, nasty way. Because I think one of these Palma people got hold of it. So I have a kind of, that's a suspicion, but anyway. But it has been quite a journey because what we've tried to show is that there are patterns that nobody's seen. And these patterns are very simple and they're persistent and they apply in a remarkable way across countries, across the world, and across individuals. And I think many of the questions you raise are questions we didn't have an answer to, Amr did in some cases. But you have to then answer how to integrate this into standard studies of discrimination and income distribution, which is not done. And nothing like this appears as a general principle. And I think it's a very strong principle. So I don't do that kind of work, and I'm not likely to do it, but it should be integrated into policy too. Thank you very much.